The last test that we're going to take a look at is something called the root test. It's a pretty easy test to do, but it really only works in a pretty specific circumstance. But let's take a look at what the test actually says. Again, we're starting with some summation. That's a horrible summation. Let's start again. Some summation, n equals 1 to infinity of sum a sub n. Now, if we do the limit as n goes to infinity of the nth root of the absolute value of a sub n, if this is less than 1, that means it's going to converge. And since we have the absolute values on here already, we can say that it converges absolutely. If the limit as n goes to infinity of the nth root of the absolute value of a sub n is bigger than 1, it diverges. And of course, kind of like our ratio test, we do have the weird case. The absolute value of a sub n is equal to 1 is inconclusive, which means go find another test. All right, let's just take a look at a couple real quick examples here because it is a pretty easy test to use. So determine if it converges or diverges. Let's do the sum n equals 1 to infinity. Let's do like 4 to the n over n to the n. Now, just off the top of your head, anytime you look at a series like this, you should try to kind of guess what you think is going to happen. Now, as far as how fast things go, exponentials do grow pretty quick, but this, anytime you have the base and the exponent the same, that's about the fastest growing thing you're going to ever run into. In fact, that grows faster than our factorial. So I'm really thinking this is probably going to converge. Now, which test to do? Now, you could try the ratio test. That would probably work out. You'd end up with a few problems that you have to worry about with that limit. Probably end up having to do L'Hopital's rule. But I notice that I can see that everything here is raised to the nth power. So if everything's raised to the nth power, taking the nth root of it will make it nice and easy to do. So let's try the root test. So I'll do the limit as n goes to infinity, the nth root of the absolute value of 4 to the n over n to the n. Well, since everything inside there is positive, I can get rid of the absolute value. So this is really just the nth root of 4 to the n over n to the n, which if you want to write it like this, n goes to infinity. This is the nth root of 4 over n to the n. Now, since our power and our root are the same, they're going to cancel. Now, the good question you need to ask is, remember, if this is odd, they just kind of go away. If they're even, you end up with an absolute value here. But n's changing, right? It's going to infinity. So it's changing from even to odd, even to odd. But 4 over n is always positive, so it wouldn't matter anyway. So this is just going to be the limit as n goes to infinity of 4 over n, which is 0. That's less than 1, so that's our case here. So we can say that our original thing is absolutely convergent or converges absolutely, either way that you'd want to say that. So as you see, it works out pretty nice, especially if everything's raised to the nth power. Let's take a look at another one real quick. What if I just said we had the sum n equals 1 to infinity, 4n plus 3 over 2n minus 5 to the nth power. All right, again, if we're going to determine the convergence or divergence, I say, look, everything's raised to the nth power. Now, we've seen something like that in the past, and we're going to talk about that in our next example. But as of right now, I'm thinking, hey, that root test will probably work out pretty well. So the limit as n goes to infinity, nth root 4n plus 3 over 2n minus 5, that's my absolute value there, to the n. All right, so as n goes to infinity, now the bottom will be negative, but it'll only be negative at the very first thing. Everywhere after that, that's always positive, so we can get rid of those absolute values. So the limit as n goes to infinity. This is 4n plus 3, 2n minus 5 to the n. Again, the root and the power cancel, limit as n goes to infinity, 4 to the n plus 3, 2 to the n minus 5. Now, of course, as we go out to infinity, the 3 and the 5 on the bottom are going to matter. We have 4n over 2n, which reduces to 2. All right, well, 2 is bigger than 1, so we can say that this diverges. This diverges. All right. Now, what I said in the last example, by the way, and you're done. What I said in the last one, this kind of looks like a series we've already talked about, and it actually was one of the first series that we ever did. And it would be this. What if we have the sum n equals, excuse me, n equals 1 to infinity, ar to the n? Well, this was our geometric series. Right? And we know from our geometric series this converges if the absolute value of r is less than 1. Now we can actually prove that using this idea here. First, let's start. When we're dealing with series, we know constants can come out front, so n equals 1 to infinity, r to the n. So that's just a constant multiple. That's not going to change whether or not our series converges or diverges. So if I do the root test here, I would do the limit as n goes to infinity, the root of the absolute value of r to the n. Well, I can rewrite our absolute value there. So this is the limit as n goes to infinity, the nth root of the absolute value of r to the n. Right, because it doesn't matter if you raise it to the power and then a root, it works either way. Now those two can reduce, and I get the limit as n goes to infinity of just the absolute value of r, which is the absolute value of r. So we wanted to know when this converges. Well, according to this test, this will converge when that is less than 1. So notice that'll converge the absolute value of r is less than 1, which we already figured out way back in our very first test, but we did kind of say, well, it's got to be a fraction for it to go away if that piece went to infinity. Go back to that first video and you'll kind of see what I'm talking about. But here you go. We've now proved that that has to be true for a geometric series to converge. All right, the root test is a very helpful test, but it's only really helpful in a very specific situation where you have things raised to the nth power. But if you have stuff raised to an nth power, it really makes things nice and easy.